Okay, today's lesson is 2-5B. It is the second part of 2.5, which was titled Rational Functions, but the second objective is to solve rational equations. So there are no functions in this, and just so you know the difference between a function and an equation is just one variable, so you only see one variable in here. When we had functions, we had a y, okay, and that's what we were graphing them. Okay, so let's go forward with solving rational equations. And the main thing that you want to do when you solve rational equations is that you want to multiply each term in the equation by the LCD to remove any fractions, because most people don't think fractions are their friends. But LCD, remember, is least common denominator, or the least common multiple of the denominators. So I try to just start off with some basic, rather simple ones, and we will get harder as we go through. So first off, I have taught this several different ways, and people always struggle with this step right here. So I'm going to add something to it, hopefully to make it easier for you, but keep in mind that once you get past this, it's pretty easy. So it's just this one step that can be challenging. So first off, when we look at this problem here that says negative 7 over 4 plus 2x plus 1 over x equals negative 3 over 4x. Okay, so we got to find the least common denominator. So what I'm telling you is, when you look at your denominators, I have 4 and I have x, and then I have 4x. So my least common denominator is going to be 4x. So that means basically when you're finding the least common denominator, you need to make all of the bottoms look the same. So they all need to look like 4x. So how do I do that? So the first one, I'm going to multiply by x over x. Then I have 4x on the bottom. The next one, I'm going to multiply by 4 over 4. And then I will have 4x. So now they all have a 4x on the bottom. And so when they do, then I'm going to take the whole equation, and you can write it on both sides if you want, but I'm basically multiplying both sides of the equation by that least common denominator, which is 4x. Now, I'm going to tell you this. 4x, when you multiply this term by 4x, there's a 4x on the top and a 4x on the bottom, so they go away. So this step, you don't have to think about doing that each time, but just when you write this step or you think about it, then what you're doing is all you have to do is write down the numerators, because the denominator is going to cancel in each term. So on the first one, I'm going to have minus 7x, and then I'm going to have plus, and I went ahead and multiplied it out. I probably shouldn't have. I don't in the future. So 4 times 2x and 4 times 1 equals, I didn't have to do anything to the other side, so it's just equal to negative 3. So that is the key. You haven't multiplied by the right thing if you still have any fractions. So my fractions are gone. Now I'm just going to simplify, and I'm going to combine negative 7x and x. 8x gives me x, and if I subtract 4 from both sides, then I'm going to end up with, that's not what I wanted, I'm going to end up with x equal to negative 7. Okay, so the important thing that you have to remember on these is that you always need to check. What are you checking for? Now, obviously, you can take this negative 7 and go put it into the equation wherever you see x and see if it works. But the main thing that you're looking for, okay, that it's and that would be a better way to make sure you have it totally correct. But the main thing, or a quick check, is to make sure that what answer you got, negative 7, when I plug it into the denominator, does it make it 0? Well, if I put negative 7 in right here, it does not make it 0. So that means that x equals negative 7 is my answer. Now, you could still have the wrong answer if you don't plug it back into the original equation, but another alternative is to go and graph it. So what I did here is I took this equation here, and I took this term to the other side. And if I take it to the other side, that means I'm adding it. Okay, so if you look up here, this is my equation, which is negative 7/4 plus 2x plus 1 over x, and then plus 3 over 4x. Set it equal to y to graph it, and if you look at your graph, that's where our answer is, negative 7. So you could get something like an answer of 5, and it doesn't make your bottom 0. So if you go to the graph, you'll know that you have it correct. Okay? Just an easy way to check, and a nice tool that you have handy with you all the time. All right, so let's keep going. So this next one, number 2, 1 plus 1 over x plus 7 equals 2 over x plus 7. So my least common denominator, or what's on the bottom, is x plus 7, and he has an x plus 7, but he doesn't. So I have to multiply him by x plus 7 over x plus 7. Okay, then, well, I don't know why that went away. So now I'm going to multiply by that least common denominator, which is x plus 7, and so I'm just going to write my numerators. So on the first one is x plus 7 times 1, which of course is x plus 7. The numerator of the second term is 1, and the numerator on the other side is 2x. And so if I subtract x and combine those two terms, then I'm going to get x equal to 8. Okay, I need to check it. So when I check it, does 8 make the denominator equal to 0? It does not. Okay, we can also check it. So I came over here and I'm going to double click that one, and double click, take it off. This is the second one that we had. And when I graph it, do I have an answer of x equal to 8? I do. So you can see that I checked all the ones I did. I might not come back because y'all get the idea of how to check it. One of the things I do want to point out before I go on, y'all, if you notice, the nice thing about Class Calc and putting these problems in here is that this looks exactly like the problem. So you type it in exactly like it looks on your paper, and that way you know you're entering things correctly. So 8 does not make my denominator 0, so we're good, and my answer is x equal to 8. All right, stepping up the difficulty a little bit, we have x over x plus 3 plus 8 equals 9 over x squared plus 3x. Okay, so if you're not careful, you might multiply these two together, but if you're good, hopefully you'll notice that these are the same thing. So this right here, x squared plus 3x, factors to x times x plus 3. So that's going to be my least common denominator. So what does my first term need on the bottom to make it look like that? I'm going to multiply the top and the bottom by x. 8 is 8 over 1, so it needs something on the top and the bottom, which is going to be x times x plus 3. Okay, so now all of my bottoms are the same, and I'm going to multiply by what's on the bottom, x times x plus 3. And now I'm going to go write my numerators. So the numerator of the first one is x squared plus 8x is on the outside times x plus 3 equals, and this one isn't going to change because I already have on the bottom what I need. So when I distribute my 8x, I'm going to get x squared plus 8x squared plus 24x equals 9. Okay, now it's a quadratic equation. So I'm going to combine x squared and 8x, and I'm going to bring the 9 over by subtraction. Okay, you can solve it like this, but it's not as much fun. It's better if you notice that there's a common factor in each of those terms of 3. So I'm dividing everything by 3, which is going to give me 3x squared plus 8x minus 3 equals 0. So if you're paying attention, you might notice in Delta Math that I put an extra assignment in there, and it was a factoring review because that tends to slow people down sometimes. So it's not anything for your grade. It's just someplace for you to go get some extra practice in factoring. So it's on there available to you if you ever want it. So to factor this, you're looking for the factors. Because this is not 1, I have to multiply these two together. So I'm looking for the factors of 9 that subtract to give me 8. Okay, but more importantly, y'all, there's only one way to factor 3x squared, and that is 3x and x. And there's only one way to factor 3, and that's 3 and 1. But I got to decide, does the 3 go here or does the 3 go here? And if I need 9, then I need to multiply these. These are what's going to give you your middle term. So 3x times 3 means I know that my 3 is going to go here and my 1 is going to go there. I have a plus 8x, so I need plus 9 minus 1. And that's a short way of factoring. If you were able to follow, I hope so. Okay, so you set each of those factors equal to 0, and you're going to have that x equals 3. X equals 1/3 or negative 3. Okay, you're adding 1, dividing by 3 to get this guy, and then subtracting 3 to get this guy. So what do I have to do next? I have to check it, okay? And so when I check it, I go up to the top. If I do 1/3 plus 3, that does not equal 0. But if I put -3 plus 3, okay, -3 plus 3 makes my denominator 0, so that is not part of the solution, and only x equal to 1/3 is. Again, if you look at the graph, you'll see that x equals 1/3 is the only place that it crosses the y-axis. The x-axis. And I don't know if I mentioned that at the beginning. When you set all this equal to 0 and make the 0 a y, that's how we graph it. But that means I'm looking for where it crosses the x-axis. X-axis. X-intercepts are the zeros of a function. So that's what we're doing. Okay, number 4. 5 over x plus 9 plus 2x plus 7 over x minus 9 equals 3x over x minus 9. Okay, so when you look at these two factors, these, of course, are the same. These are different. The only way to make them, they have nothing in common, no factors, because this whole thing is a factor. So my least common factor, least common denominator, is going to be multiplying these two things together because they have nothing in common. So I'm going to have to multiply this by x minus 9 over x minus 9. This is going to have to multiply by x plus 9 over x plus 9. And this one is going to be multiplied by x plus 9 over x plus 9. So now all of my denominators are the same. And now I'm going to multiply by that least common denominator, which was x plus 9 times x minus 9. And so I'm going to write my numerators. The numerator of the first term is 5 times the quantity of x minus 9. The numerator of the second one is those two binomials together. And then on the other side of the equation, I'm going to have 3x times x plus 9. So I've got to simplify all that. So 5 times x minus 9 is going to be 5x minus 45. And then I'm going to have to FOIL. So my first term is 2x squared. Outside, 18x. Inside, 7x. Last, 63. And then I distribute my 3x squared plus 27x. Okay, now I'm going to combine. I'm going to simplify the left side before I try to take anything over. So on the left side, I'm going to have 2x squared. And then x's. I've got 5x and 18x and 7x, which together give me 30x. And then I have minus 45 plus 63 gives me plus 18. And that equals 3x squared plus 27x. Now, I have a quadratic again, so I'm going to have to factor. So I'm going to set it equal to 0. And I prefer to keep my leading term positive, so I'm going to move all of this over to the right side. So I'm going to have 0 equals, what's 3x squared minus 2x squared is going to be x squared. 27x minus 30x is minus 3x. And then to move the 18 over, I subtract. So this is what I have. And then I'm going to factor it. Okay, so I've got x squared, then it's just going to be x and x. I'm looking for the factors of 18 that subtract to give me 3. And that, of course, is 6 and 3. I didn't say that backward, but anyway. It's minus 6, okay, because that one is minus. So there's your minus 6x, and there's your plus 3x, which gives me my middle term. Okay, so that gives me x equals 6 or negative 3. I have to check that. So I'm looking back up here, and I've got x plus 9 and x minus 9. If I plug a 6 in either of those, I'm not at 0. And if I plug in negative 3 for either of those, I'm not 0. So this particular one has two solutions. So that's why I hope you can see from just those two examples right there why you need to check, because what you get is not always going to be the case. You have to check your answer. Okay, number 5. 3x over x minus 2 minus 2x plus 3 over x plus 4 equals 2 over x plus 4. So I would encourage you to pause and see if you can come up with that least common denominator. Start back up, and let's see if you got it right. So these two denominators right here have nothing in common. Okay, I can't multiply one by something else, take something out. They have nothing in common. So my least common denominator is going to be multiplying them together. So I need an x plus 4 over x plus 4 on this one. I need an x minus 2 and x minus 2 on this one. And I need an x minus 2 and x minus 2 on that one. And now that I have the bottoms all the same, I'm going to multiply by that bottom, which is our least common denominator, and then I'm going to write my numerators. So I have 3x times x plus 4 minus, again, two binomials equals 2 times x minus 2. Okay, so I distribute my 3x. I got 3x squared plus 12x. Then minus my first term. Okay, and this, y'all, this is another place that people would tend to make mistakes because of this minus here. It really distributes to everything in the numerator. So you're safer if when you multiply this out is to keep it in parentheses like this first and then distribute the negative. So now my first term is 2x squared, outside term, inside term, and last. Okay, and I'm going to combine those two, which of course give me, I didn't go to the right side, excuse me, equals 2x minus 4. So when you combine those, you get minus x. So when I simplify the left side, I'm going to have 3x squared minus 2x, and that of course gives me x squared. Then I'm going to have 12x minus a negative x, and that's 13x. And then I have minus a negative 6, which is plus 6 equals the right side. And again, I have a quadratic. I need to set it all equal to 0. So I'm going to have x squared. 13x minus 2x is 11x. And 6 plus 4 is 10, equal to 0. Okay? Again, easy because my x squared has no coefficient other than 1. So I'm going to have x and x. Factors of 10 that add to give 11. Well, that, of course, is 10 and 1, and they're both positive because that term is positive. If I'm adding, the signs will always be the same, and it'll be whatever that is. Okay, what do I have to do next? I have to check them and oh, I didn't say what x was before I checked them. Okay, that's why I'm not getting it. So what does x equals? X equals negative 10 or negative 1. Then I go and check them. Does negative 10 make either one of these denominators 0? No. Does negative 1? No, it does not. So we're good to say that those are my answers. All right, two more. A little more challenging. X minus 1 over 2x minus 4 plus x plus 2 over 3x equals 1. Okay, so do these have anything in common? Hope you answered no. So since they don't, I have to multiply them together. So the first one needs a 3x on the bottom. Second one needs a 2x minus 4. And this needs the whole thing because there is no bottom with it. So I have to multiply by 3x times 2x minus 4. Okay, so now all my bottoms are the same. I'm multiplying by that bottom number, which is my least common denominator. And now I'm going to write my numerators. So I'm going to first have 3x times x minus 1. That's my first numerator. My second one is two binomials. And then I have, what was on the top of the other one? 3x, because it's times 1. So now I'm going to simplify everything. 3x times x minus 1. 3x times x is 3x squared minus 3x. It's a plus sign here, so I don't need the extra parentheses. Multiply my first terms, outside, inside, last. Then I distribute 3x times 2x, and then 3x times negative 4. Okay? Again, I'm going to simplify the left side first before I try to combine on one side. So 3x squared plus 2x squared is 5x squared. I have a negative 4x and a positive 4x. Well, those basically cancel each other out. So I have minus 3x minus 8 equals the right side. And again, I'm going to take it where I have the bigger x squared because I want it to be positive. So 6x squared minus 5x squared is x squared. Negative 12x plus 3x is minus 9x, and then add 8. And now I'm down to factoring. Again, x is, there's coefficient of 1, which makes it easy. And y'all, I know there's websites out there that tell you how to factor, but the best thing you can do, because this probably isn't your last math class, is to practice, okay, and see if you can get these right. So I'm looking for the factors of 8 that add to give me 9. Well, that, of course, is 8 and 1. And since I'm adding, the signs are the same, and they take the sign of that middle term. So it's going to be minus 8 and minus 1. And that's going to give me x equal to 8 and x equal to 1. I'm going to go check. Does 8, obviously it doesn't make it 0 in this factor, but over here, if I have 8 in there, nope, 16 minus 4 is not 0. 2 times 1 minus 4 is not 0. So both of these answers check, and we're good to go. And if you remember from class calc, I actually checked all these. So, all right, last problem. 3 over x plus 2 over x plus 1 equals 23 over x squared plus x. Okay? If you're not paying attention, you're going to go this times this times this. So I hope you are paying attention and realizing that this last guy factors to x times x plus 1, which is what these two are. So that means I don't have to multiply all 3 of them. I'm only multiplying these 2. So this guy doesn't need anything on the bottom, but the first one needs an x plus 1 and an x plus 1, and the second one needs an x and an x. So now all of my bottoms are the same. I'm going to multiply by what's on the bottom, and I'm going to write my numerators. So 3 times x plus 1 plus 2x equals 23. And then I'm going to distribute, and I have the same thing. And I'm going to combine. 3x plus 2x is 5x. 23 minus 3 is 20. Divide by 5, and x equals 4. And then I go check. And if I plug 4 in for x, or 4 in here, then I don't get 0, which means I don't have to worry about that one because that would be the same as those. Okay, so I'm good, and x equals 4. And that is all there is to rational equations. I hope you find them easy. Please don't hesitate to email us or contact us if you have any questions. Thank you so much, and y'all have a great day.